Hello students, welcome back to the online class. So earlier in the last video class, we were discussing about the numericals belonging to the chapter Mechanical Properties of Solids. So today we are going to continue those numericals. Already in the previous video class, 5 questions are being discussed along with the solution. Already the PDF you have received. So how you are going to write that is first look at the PDF file, write down the questions, leave space. Next question, leave space, like that. Then you try solving that. Maybe using pencil, fine. Suppose you feel like you may go wrong like that. If you have any doubt, means you can do that. Next, what you do, watch the videos, learn how to solve that. Give importance for the powers, scientific notations like operations like division, all those comes, right? Shift in the decimal places. So carefully have a look and solve. So once you complete that, then you are supposed to send that snapshot to me, right? So today we will continue that. Along with that, once I finish off the numericals, let me dictate you some very important points from this chapter that will help you in examination for 1 mark questions. Because 1 mark questions can be asked randomly from any part of the chapter, any part of the line also, or a sentence. So that means some of the important, that means usually examination like previous year questions and all, if you check, means like district level, okay, first PU examination. Some of the questions which are familiarly asked, that means repeatedly asked, such kind of questions we have picked, and I will dictate that, you better write down, okay. So let us go for the numericals now, remaining numericals. So numerical number 6, 5 I have completed. Okay. So question number 6. Okay. So question number 6, let me read the question. You look at the notes so that there itself you can solve, right? So question is, the upper face of a cube of edge 1 meter moves through a distance of 1 millimeter relative to the lower fixed surface. The upper face of cube means, of course, all the sides has to be of same length, right? Fine. Under the action of tangential force, how much is that? 1.5 into 10 power 8 Newton, very high force. Calculate tangential stress and rigidity modulus is asked. Okay. So let me draw the diagram. This was the cube initially, and it's of side how much? It is mentioned 1 meter is the side, and a tangential force is applied, deforming force. What happens? It slightly bends, right? During explanation I have shown you people. This is what theta. Then what is this? Yes, that is nothing but S. That means you might be remembering. S means the value of S, deforming. What is that? 1 millimeter they have mentioned. See, 1 millimeter. So what is H value? H equal to 1 meter. What is S value here? That is 1 millimeter means what? 1 into 10 power milli, 10 power minus 3 meter. Because I am writing everything in SI system. Thereafter, what is the force applied in this case? Look at here. The force, tangential force applied is 1.5 into 10 power 8 Newton. So 1.5 into 10 power 8 Newton. So why I am writing all this this means these are the given data, so that once you write down all the given data, then if you remember about the formulas, it becomes more simpler to solve the numericals. That's why. So have a look. So next, what we can understand from this? That is, force we have value, we require, what is that? rigidity modulus we require. Rigidity modulus means what is that? Stress divided by, that means ratio of stress and strain, correct. So that also we are supposed to find out. Along with that, we have to find out one more thing. What is that? Shearing stress or tangential stress also you have to find out. So first let me go for tangential stress. So tangential stress means force by area of the face, correct? That is tangential stress is equal to force. That means what is that force? Tangential force. Tangential force applied divided by area of the face. You might be remembering formula F by A, right? Yes. How much is that? Tangential force 1.5 into 10 power 8 divided by what is that area? Height, meter square. That means 1 itself. That means what is the final answer? This is nothing but 1.5 into 10 power 8. What is the SI unit? If you don't write the SI unit here, you will be losing how many marks? 1 marks. That's why this is Newton per meter square. See? Tangential stress or shearing stress we found out. So next, what is rigidity modulus? That is the question. So Young's modulus, you know, longitudinal stress by longitudinal strain, correct? Like that, rigidity modulus means what is that? Tangential stress by tangential strain. Am I right? So let us write down that. Rigidity modulus is what? Tangential stress divided by tangential strain. Next, what is tangential stress? Of course, value is ready here. What about tangential strain? Oh, now you have to think about that. Strain. So you know longitudinal strain means what? Delta L by L. You can check the notes. Volumetric or bulk strain means delta V by V. Whereas when you come across tangential or shearing strain means we just think about the, yes, how much angle it has. What is that? Yes, deformation has taken place. So you might be remembering that. So theta is equal to S divided by what is that? Tangential strain. You can write down tangential strain S by H, or the same equation can be written as tan theta also. Okay, there is nothing because trigonometric functions, however, you know this is tan theta equal S by H. As theta is very very small, tan of very small angle is always equal nearly equal to theta. That is why sometimes theta equal S by H we write. Tan theta is equal to S by H if you write also, it's one and the same as theta. That means angle of, okay, that bending is very 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 small actually. In diagram it may look like this, but actually very small practically. That is why the tan theta will be neglected, which we taken just as normal degree angle like that. Okay. So theta equal to S by H, theta equal to 1 millimeter. It is 1 into 10 power minus 3 divided by H 1 meter. That means answer is theta equal to 0.001. S by H, meter by meter. What happens? Cancel. So value theta is just like this, unitless. Next, therefore rigidity modulus capital G representation is equal to tangential stress by tangential strain. Tangential stress is 1.5 into 10 power what? 8 divided by strain, tangential strain 0.001. Now what will be the value? Check the calculation. You have to do it on your own. Your answer will be 1.5 into 10 power 11. Yes, what is this? Stress by strain. Strain means unitless. Stress means unit is there, Newton per meter square. So, Newton per meter square is the final answer. Hope this is clear. Sixth question looks lengthier, but these are actually the things what you have learned in board class already in the previous videos. We are applying our knowledge. We are applying as in the form of a question, that means equations. So, by looking at the given data and all, we can solve this. So, take down. Hope this is clear. Individual steps. Okay, fine. Yes. So, let me erase this. Let me go for the next numerical. Question number 7. So question number 7 is, when a rubber ball is taken to a depth of 100 meter in sea. Of course, you know, when you suppose you are good in swimming, means you can observe that. Suppose you are diving, okay, not diving inside a pool, swimming pool or lake, okay, whatsoever, or river, sea also fine. When the depth is more, when you try reaching the bed of that, particularly base of the swimming pool, whatever, when it's becoming more and more deep, more and more pressure will be there inside that particular water reservoir whatsoever. So when you go deeper, more pressure will be there exerted on you. Suppose you don't use proper air blocking kind of materials as well as proper, okay, that eyeglasses, that means while swimming, usually it will be used. If you don't use them properly, means the pressure will be there which will be exerted on your ears, eyes, all those. Okay, so what have see the possible recently the Guinness World Record, that is deepest diving was recorded somewhere around 300 meter. Okay, as per me, I don't know, maybe recently some new people also might have went for much deeper, because without going with the submarine and all, that is different. Without going, that means without what and all the safety measures like that, directly diving inside means very large amount of pressure will be exerted on you as you go deeper. That's the difference. Okay, so what happens, there will be high pressure on you. That means your bloodstream, everything starts shrinking. Okay, these are just general knowledge I am speaking. Okay, that means this need not be there in these questions right now, but I am just letting you know that there will be increase in pressure whenever you go deeper and deeper inside a given liquid. So let us continue the question right now. When a rubber ball is taken into a depth of 100 meter in sea. Yes, we can understand now. Yes, that means high pressure is there. From which direction? All the directions. So rubber ball, like this, spherical in shape. That means slightly there will be of course, pressure from all the 360 degrees, three-dimensional space. Volume decreases by 0.1%. 0.1% is given. Out of 100, 0.1 is actually reduced due to hydraulic stress. So I understood now. Hydraulic stress means pressure, that is it. If the density of the seawater is 1000 kg per meter cube, of course seawater as well as normal water, which you will be using for chemistry equations and all, no, that is 1000 kg per meter cube usually we say. Water means density of water is 1000 kg per meter cube, yes. Calculate bulk modulus. Bulk modulus means the rigidity modulus due to the volume. And compressibility of rubber. Compressibility means it's nothing but reciprocal of bulk modulus. Okay, let me explain that. So first, given data I will write down. So change in volume. Change in volume. That means delta V is equal to what they have given, 0.1% of original volume V. 0.1% of original volume of V. So how to write now? That means delta V is nothing but equal to 0.1 divided by 100. Can you understand this? You might have used such kind of equations whenever you have come across that banking concept, right? Percentage, interest, all those. So there also you will be using this. Whenever percentage is given means is how to get that into numerical form from percentage form. So that is what I have written here, 0.1 divided by 100. So however, you will be getting 10 power minus 3 V. Correct? This much. And next, we know when the ball goes deep inside the sea, enormous pressure will be there on it. So who will exert pressure? Of course, the medium itself, the sea, that means water medium itself exerts pressure. So even in atmospheric pressure also there, right? 101.3 pascals, kilopascals, right? Or ATM we say, atmospheric pressure. So what is that? Atmospheric pressure. So in atmospheric pressure, that means air medium exerts pressure on us. Like that, water medium also exerts pressure which is much more compared to air. So we require the deforming force. Like previous question, F is equal to 1.5 10 power 8 Newton was there. But here, what is the deforming force? Liquid pressure is nothing but deforming force which makes the ball to shrink by how much? 0.1%. So how to find out that? In upcoming chapter you will be knowing this equation, okay? So don't get confused now from where this new equation he has got. This equation in upcoming chapter you will learn. But right now this question was very interesting. That is why I have included it. This equation, however, you will learn in upcoming chapter. But right now it was relevant to use here. That is why I am using. So in this chapter, mechanical properties of solids, this equation was not there, sir. Then why you are using, sir, and all such kind of questions? If it arises means I already cleared the doubt. So P is equal to pressure of liquid is equal to rho G H. So what is rho? You know, rho means density of liquid. Next, G means you know acceleration due to gravity. Next, H. H means yes, height. Okay, so what is the deforming force here? The force exerted on the rubber ball at the depth of 100 meter inside a sea. Inside sea. So what is the force? Liquid pressure itself, force. At the depth of H, 100. Acceleration due to gravity, 9.8 meter per second square. What is the value of rho? Of course, it is mentioned, 1000 kg per meter cube, right? So, deforming force is ready now, right? So, let us calculate. 1000 into 9.8 into 100. So, check, calculate now. What's the answer you have to tell me? No, you cannot tell me, but you have to write down there on the notes. So, answer is, check your answer. So multiply, this is 9.8345 into 10 power 5. Pressure, what is the SI unit? Same, Newton per meter square. Force by area concept is also same here, okay. So we got to know what is the, because you might be knowing, stress and pressure shares the same SI system. So deforming force is ready. Then what we require to find out here? Bulk modulus we have to find out. So bulk modulus means, yes, you can see there, pressure is ready. So bulk modulus, already we have solved such kind of numericals. We can take directly like pressure divided by the volumetric difference. In the sense, volume change or bulk strain we can take down. So stress by strain, the same concept. P by or pressure divided by delta V by V equation. So how much is that now? 9.8 into 10 power 5 divided by delta V by V. Here we have got what? Delta V we have So what I write is delta V by V means what will be the equation now? That is already delta V means we have, what is that? 10 power minus 3 into V divided by V again. So what cancels? VV cancels. So finally what we get? Bulk modulus B is equal to, look at here, 9.8 divided by 10 power minus 3. Minus 3 goes up. That means plus 3. So answer is 9.8 into 10 power 8 Newton per meter square. Check the answer. Hope you are able to understand this. Okay, that is all about that. Bulk modulus. And last, in the same question, I told you compressibility something is asked, correct? So compressibility means it is nothing but reciprocal of bulk modulus. So compressibility actually given by, take down, it's like a small note point, okay. Compressibility is equal to 1 by bulk modulus, or K equal to 1 by B. So this is nothing but 1 divided by 9.8 into 10 power 8. So K equal to 10 power 8 goes up. First you substitute for 10 power. Goes up means minus. So it is 10 power minus 8. So 1 divided by 9.8 means how much? Use your calculator and check the answer. This will be somewhere around 0.1. Earlier it was Newton per meter square. Right now it is, check that. So reciprocal of that. So that becomes Newton per meter square. So this becomes meter square per Newton. Okay, this is reciprocal. Hope this is clear for you. It's all about the question number 7. One last numerical regarding Young's modulus is remaining. Let us go through that. Okay. Hope you are ready. Last numerical. 8th one. I can give you more number of numericals, but right now the regular classes are not being commenced. That's why now around 8 numericals for your practice purpose I have discussed. So where you can come across the different terms which we have learnt, as well as their applications in the form of numericals we discussed. So let me go for the 8th question. Question number 8. Let me read the question. You look at the question. So a steel wire of length 5 meter, cross-sectional area. So length and area is given directly. So what is your first job to do? First you have to write down the given data. Length 5 meter. Next, area of cross-section, capital A is equal to 3 into 10 power minus 5 meter square. Is stretched by a same amount of copper of, is stretched by same amount as copper of length 3.7 meter cross-section area. That means a steel wire of this much dimensions, length this much and area of this much, is stretched by one particular force. Okay, same force is actually stretching which one? A copper wire. Okay, copper wire is of copper wire. So I will take this is steel, this is steel. Length of copper wire is LC. How much is that? 3.7 meter. And area of cross section of copper wire is equal to 4 into 10 power minus 5 meter square. Okay. So next, find the Young's modulus of steel. Find the ratio of Young's modulus of steel to copper. That means Young's modulus of steel to Young's modulus of copper equal to how much you have to calculate. And of course, you know, Young's modulus means what is the formula? Young's modulus equal to stress by longitudinal stress by longitudinal strain. That means delta L by L. So hope you remember this formula. So what I do, I'll just directly substitute this. Okay, steel by copper. Next, so what is that substitution? Is force into length of steel divided by area of steel into delta L stretched by same, no, that's why. So L we can write. Next, force into L into C divided by A into C into delta L. Check that. Substitution. Okay, now finally what we can get is substitute the values. Okay, do the calculation on your own. You have to get, look at here, you have to get 4, right? Yes, of course. 5 into length, 5 into area, that is 4 into 10 power minus 5 divided by, how much is that? 3.7, correct? Length of copper into its area. Area of which one? Yes. That means this is 3 into 10 power minus 5. Answer will be 1.8. Check this. Check whether you are getting same answer. Hope you can make out why after substitution delta L cancels. So you can make out, no? F into, okay, this comes here, this goes there. So force also cancels, sorry. So this is L into S, A into C divided by, next, L into C, A into S. That's why it is like this. Same force, correct? They stretched by same amount. Also it is mentioned. Delta L is one and the same. That is why, okay? So hope this is clear. Question number 8, what I have solved. Here, your high school mathematics, there is nothing new here. So carefully apply that. Cancel the common terms. They are stretched by same force. They are stretched by same amount. That means extension, extra length which is increased is one and the same. So delta L cancels. That is why I have taken like that. Okay. Suppose you want to write separately, means you can do that. What is that? Y steel equal to force divided by area of steel divided by delta L by length of steel. Next, copper. Young's modulus of copper is what? Force same, area of copper separate divided by stretching is same by L copper. That is it.